Okay, this is 17.2a, the Canadian version, 17.2a. But if we're putting this in summation notation, that means we understand and how this thing works, where we have n equals 1 to a certain amount. And since there's 1, 2, 3, 4 terms, the top's going to be 4. However, contrary to what we learned to do yesterday, this is not an arithmetic sequence. So we want to understand that when I plug in a 1, I want to get a 2, but when I plug in a 2, I want to get a 10. So what we see, we're multiplying by each time. We're multiplying by 5. And so it's going to be a multiplier of 5 to the n power. But we also want to make sure that when we have our 0 term here. So technically I'd be dividing by 5. So this would have to be a 2 over 5 times 5 to the n power. So if I plugged in a 2, it'd be 5 squared, which is 25. And 25 divided by 5 is 5 times 2 would give me 10. So each one of these should work the way we do that. Now the sum of the series is simply adding those 4 terms up. So 250 plus 50 is 310, 312. That's the sum of the series. This formula here is the one that works, where a sub 1 is the series first term and r is the series multiplier. Prove that this series formula works. Good job, Jackson. And that's my number 2 son playing a game while I'm making videos. That's fun. Anyway, it's less about the equation and more about, do we understand how this works at this point? So let's give it a shot. A sub 1 is the first term, and a sub 1 is what you get when you plug 1 in, but it's also the first term. So that is a 2. Okay? When you say 1 minus r to the n power, our common ratio is 5, and so that's going to be, it's 1 minus 5 to the n power. So the n, there's 4 terms. 5 to the 4th power, that's going to be big. All over 1 minus the common ratio, 1 minus 5. So there's some calculations that need to be done here. Okay? 5 to the 4th power, I believe, is 625. Well, let's see how that works. 5 raised to the 4th power is 625. Okay, I got lucky. So when I use that information, I got a 2 times 1 minus 625 all over 1 minus 5, which is, I guess I could say that's a negative 4 now. Okay, so when I go through that process 2 times, that's going to be negative 624. Negative 624. And then divided by negative 4. That's equal to 312. So that shows that the equation works, and because we were able to do it, it was a simple calculation to get to that. So we see that. It looks crazy and it looks ugly, and that's definitely a more difficult equation than the sum of a finite arithmetic series. But we can see that it worked now.